We are given y equals x squared minus 3x plus 7, and we're asked to find, is y a function of x? Well, the condition would be that the x's must be faithful. Well, what does it mean for the x's to be faithful? In this situation where you're given an equation and asked if it represents y as a function of x, you need to consider every possible x in the domain being plugged into this equation, simplified, and see if it only produces one y partner. Well, and when I examine this equation, I can see that every x I plug in gives me a unique y partner, not more than one. Here's an example. Let's let x equal 1. Then we get y equals 1x, 1 squared, minus 3 times 1 plus 7. 1 minus 3 plus 7 equals 5. So y is equal to 5. That's just one solution. Let x equal negative 1 and plug it in. Simplify, you get 11. You get y equals 11. So as I continue testing a few, I can see the pattern that is, no matter which x I put in, it's only going to produce one y partner. So therefore, the answer to the question, is y a function of x, is yes. And I put a box around my answer. Now let's do another one. Given x equals y squared plus 1, find out if y is a function of x. Well, in order to test this one, I need to get y by itself. So I'll move 1 to the other side and turn the whole thing backwards. That's what the squiggly line is for. And I get y equals, now I'm going to take plus or minus the square root to get rid of that second power. So y equals plus or minus the square root of x minus 1. And now I'm going, wait a minute, that plus or minus is very troublesome, because if I put an x in here and simplify it, y will be equal to the positive and the negative of that number, which means x's will produce more than one y partner. It's because of that plus or minus there. So the answer of to the question, is y a function of x? The answer has to be no, because there are x's that produce more than one y partner. In other words, there are unfaithful x values.